The research paper, Towards Universal Representation for Unseen Action Recognition, proposes a new method for unseen action recognition, UR, which aims to recognize new action categories without training examples. The authors propose a pipeline that uses a large-scale training source to create a universal representation, UR, that can be applied to a cross-dataset UR, CDUAR scenario. This UR can recognize unseen actions from new datasets without further training or fine-tuning. The authors first address UAR as a generalized multiple instance learning (GMIL) problem and use distribution kernels to discover building blocks from the large-scale ActivityNet dataset. They preserve essential visual and semantic components in a shared space to create the UR. The UR can then be improved by a simple semantic adaptation, and an unseen action can be recognized using the UR during the test. The authors claim that their method significantly improves upon the UCF 101 and HMDB 51 benchmarks without further training. The authors also discuss the limitations of previous methods, which focus on inner dataset seen/unseen splits and require retraining for each new dataset or category. They propose a more practical solution that uses a large-scale training source to create a UR that can automatically generalize to a CDUR scenario. The proposed pipeline is illustrated in Figure 1. It involves extracting deep features using deep neural networks, which results in a GMIL problem. The authors then introduce their novel Universal Representation Learning (URL) algorithm, which uses non-negative matrix factorization (NMF) with a Jensen-Shannon divergence (JSD) constraint. The UR can substantially preserve both the shared and generative bases of visual semantic features, making it suitable for the challenging CDUR scenario. The authors conclude that their method can effectively generalize across different datasets and outperform state-of-the-art approaches in inductive UR scenarios using either low-level or deep features. The research paper presents a new approach to zero-shot human action recognition, a rapidly advancing field due to its importance and necessity. The common practice of zero-shot learning is to transfer action knowledge through a semantic embedding space, such as attributes, word vectors, or visual features. However, attribute-based methods have several drawbacks, including the complexity of actions, the need for retraining when adding new attributes, and the potential for semantic meanings to be unknown or inappropriate. Therefore, word vectors have been preferred for zero-shot action recognition. The paper proposes a universal representation learning (URL) algorithm that combines non-negative matrix factorization with a Jensen-Shannon divergence constraint. The URL algorithm was shown to outperform existing methods in a cross-dataset unseen action recognition scenario. The researchers also conducted in-depth analysis with baseline approaches and found that their method is not sensitive to the basis space size.